First and foremost thing, I would like to bring an attention of industrial control panels. Unlike many panels like motor control centers or power distribution equipment, industrial control panels pose a higher risk to the workers while performing a maintenance task. This is primarily due to two reasons. One is industrial control panels have multiple voltages available in them. For example, an industrial control panel can have a 480 volts or a 600 volts alongside a 24 volts control system or a PLC. For that reason, a person, for example, a maintenance person who is trying to make any tweaks to the process parameters, who doesn't need to even access any live or energized components, will be able to open that panel to just make tweaks to that specific section of the panel. But the problem is the inadvertent contact with energized parts when that specific individual opens the door of the cabinet, right? Unlike your MCC, you know that it's only a qualified person who is performing the task. Here, it could be a machine operator or a control programmer who is performing the task. By providing a panel interface connector like GracePort, it will greatly minimize the risk of exposure of opening that specific cabinet. So a control programmer or a maintenance person can safely hook up their PLC or a computer to these programming ports and safely perform those programming functions from outside the cabinet while the system is still energized and not opening the door. Again, this meets the Article 110.4d as defined in normal operation criteria, where everything is closed, they're not accessing any energized components. And one more thing you asked about is the GFCI, which is a ground fault circuit interrupter. This is very important with the industrial control panels because it is not like a nice to have feature anymore, it is a must have. If you look at NFPA 79, which is the standard for industrial control, industrial machinery, and also UL 508A for industrial control panels, they call it very clearly any type of receptacle that's mounted outside the enclosure or a control panel must be a GFCI protected. If you use anything that's inside it, then UL 508A doesn't require that to be GFCI protected, but anything that's used for accessory equipment that needs to be GFCI protected. So by using a Grace panel interface connectors, one can safely meet the requirements of 508A and also NFPA 79 and further enhance their worker safety and productivity as well. My name is Bhanu Srilla. I'm the Director of Product Marketing here at Grace Technologies. So you might be wondering how GracePESDs or permanent electrical safety devices comply with occupational safety and health administration initiatives and also NFPA 70E's process for establishing and verifying an electrically safe work condition. So Occupational Safety and Health Administration CFR 1910.147 defines the control of hazardous energy. And again, this is one of the top 5 violations under OSHA. 1910.147 applies to all sorts of control of hazardous energies with an exception of electrical energy. For electrical energy, CFR 1910.333 subpart S applies to that, which is in direct connection to Article 120.5, the process for establishing and verifying an electrically safe work condition. Under Article 120.5, if you look at the 2 major steps which our products comply to. If you take the voltage indicators, these are primarily for voltage presence indication alone. If you look at the step 4, which is the release of stored electrical energy, with the use of these voltage indicators, one can visually verify the release of stored energy using this LED lights that bleeds away the dissipated energy. For example, of capacitive loads or variable frequency drives, you can safely verify the release of all the energy using a visual presence. And if you look at the step 7, which is for verifying the absence of voltage test, which requires an adequately rated portable test instrument in conjunction with our safe test points here. If you put this safe test point outside your cabinet, you can safely perform that step 7 using an adequately rated meter with a max exposure of less than 3.5 milliamps. So this is basically a dead live test that's been called in the industry. So you verify the live and you verify the de-energized state after throwing the disconnect off, and then you go back and verify your meter to ensure that the meter is working satisfactorily to any known source. So that's how it complies with that, right? So once you install these devices outside the door, and you perform these tasks in a normal operation. Article 110.4D specifically calls out 6 steps equipment needs to meet to comply to this normal operating condition, which is the equipment is properly maintained, the equipment is properly installed, the equipment is used in accordance with the manufacturer's instructions, the doors are completely secured, and there is covers and other pieces of this equipment are secured as well, and there is no impending failure of that equipment. Once all the 6 criteria are met, you are performing the same task in normal operation, which will greatly benefit you in minimizing the amount of PPE that's required and also performing the task in a much safer way than exposing your personnel to the incident energy inside that cabinet. NFPA 70B 2019 edition included a new section to the standard, which is under System Studies Chapter 9, which requires for maintenance-related design studies. As part of this, before installing an equipment, the facility owner has to evaluate the criteria that will minimize the risk of exposure to their employees and workers while performing any type of task around this equipment's operation or maintenance. So, GraceSense Hotspot Monitor will greatly help to minimize the risk of exposure as outlined in that section 11 within that chapter 9 standards to ensure that the thermal sensors can be used to connect to any critical connections to monitor the hotspots without opening the door or without exposing the people to monitor the temperature anomalies using infrared camera. By monitoring this temperature anomalies through this continuous monitoring sensors, one can greatly minimize the risk of exposure and then be able to monitor the equipment anomalies. NFPA 70B introduced under Chapter 9, which is System Studies, a section 9.7, which calls out for maintenance-related design studies. As part of the maintenance-related design studies, a facility owner has to identify and develop the solutions that will minimize the risk of exposure of electrical hazards to the persons while performing the daily operations or any maintenance tasks. Under that specific section or the chapter, there is an item which is 11 that specifically calls out for the use of thermal sensors that can be used for monitoring the anomalies or temperature anomalies of critical connections. With the use of hotspot monitor, one can greatly minimize the risk of exposure by not doing this infrared thermography by opening these enclosure cabinet doors.